In this episode, we're going to do something really interesting where we're going to be chatting with a LLM for text generation. However, this one is a little bit different than anything we have done before. So instead of calling an API or using some kind of local LLM service, we're actually going to be loading a model into the browser. So you can see that the RAM has jumped once we have finished downloading the model onto this computer that's running it. And we're going to be able to use our own hardware to perform the text generation. So I'll load it again, and you'll notice that currently we're at 35 gigabytes of RAM used. When I reload this again, it dropped down to 32 gigabytes, and then it loads the model, and now it's back up to about 35. So we can test this with tell me a joke, and then you see that it responds. We can generate additional ones, and each time it's going to use my computer's GPU. And so there's several reasons why you would want to do something like this. If you wanted to provide this kind of text generation, however, don't want to support the infrastructure that something like this requires, then leveraging the end user's computer and their GPU for this is a great path. Now, there are some caveats to it though. The browser does have to support WebGPU. It is possible to do it in Linux on Chromium, but you do have to set a flag and start the Chrome browser with Vulkan support. But I found in those kind of cases, it's able to use the internal GPU. So in my case, I tested this on an Ubuntu machine with an Intel 155H processor, and it was able to generate it around 30 tokens per second, which isn't too bad at all. I also tested this on Windows computers, and on both Edge and Chrome, it worked without any problems. I did find on macOS it doesn't work under Safari, so you are limiting your end user what browser they're able to use with this. And in my case, I'm using a very light model, the Llama 3.2 3 billion instructions. I could change this to a much larger model, which would take a lot more RAM, and it would also take a lot longer to download, but again, it does download it one time, and each subsequent visit would be much faster. So you do want to keep in mind that not all users may have a powerful computer that would be able to sacrifice that amount of VRAM in order to run these kind of models. However, if you are using a smaller model and the tasks you're trying to perform aren't too difficult, then this could be a very viable solution for you. And so in this case, I'm now running a Llama 3.1 8 billion parameter, and we'll give it the same prompt, and you'll see that it does run a little bit slower. However, it is still giving us a pretty decent speed, and we can even tell it to give us a much larger response, and this works as we would expect. So this is what we're going to be diving into in this episode, and the use case for this is probably pretty limited. However, if you do find a use case for it, it can be extremely powerful. In my case, what I find myself most often using large language models for is to manipulate data instead of generating text or answering questions like I've been doing here, but having it generate structured data or reformatting data. These small models have been doing extremely good at handling those kind of tasks. And did you know that you can go to railsstore.com to get your own Ruby on Rails t-shirt or your Drift and Ruby t-shirt? To watch this full episode and more videos, visit driftandruby.com and subscribe to the Pro membership.